Yeah, good afternoon, everyone. I hope I am audible. Yeah, good afternoon, everyone. I am your host, Alok Kumar Jha. We will be beginning with the webinar very soon. We'll just wait for 2 minutes and then we'll start with the webinar. Thank you for your patience.
Alok, is my screen visible? Sorry, I can't hear you.
Yes, sir, your screen is visible.
Okay, sure. Thank you.
So, good afternoon, everyone. I, Alok Kumar Jha, on behalf of Advent Informatics, I welcome you to today's webinar on our fascinating topic, chemical data management on your desktop. We are thrilled to have you join us and look forward to an engaging session. Before I deep dive into the topic, let me take a moment and introduce you to Advent Informatics. So, Advent Informatics Private Limited is a Pune-based distributor of life science softwares. We provide software solutions in domain of chemoinformatics, molecular modeling, medicinal chemistry, chemical data curation, chemical and biological data management, and many more, to most of the major pharma, chemical, and CRO companies in India. We also have worked with major academic and government research organizations and focus on providing well-renowned software to Indian researchers, students, etc. We currently represent softwares and solutions for Molsoft LLC, Chemaxon KFT, Chempass, Certara, Transgene, IT Solution, and Key Module. Yeah. So now let me introduce you to today's topic, chemical data management on your desktop. Chemaxon is a global leader in providing solutions for chemical data management and chemical structure searches. In this webinar, we will discuss how Instant Jchem Enterprise from Chemaxon helps medicinal chemists, academics to manage chemical data and associated research data and lot of more. I will let our speaker talk more about this. So now let me introduce you to our speaker. Our speaker for today's webinar is Mr. Surojit Sadhu. He is a founder of Advent Informatics. He founded Advent in 2016. He is a bioinformatics graduate with expertise in handling chemoinformatics tools. He has spent a couple of years at CSIR, National Chemical Laboratory, and then worked in a Mumbai-based company as an application scientist, assisting in sales of chemoinformatics softwares. He then transitioned into sales and later started Advent. He has been working in the life science domain for more than a decade now and helps organizations derive more value from their data. He has also specializations in strategic collaboration with principal partners from around the globe and marketing their products in India. He heads the sales and specializes in establishing and marketing new brands in India. If any one of you has any question they would like to ask Surojit sir during his talk, please submit them into the Q&A section. You can find the Q&A option in the toolbar at the bottom of your screen. Surojit sir, the floor is yours.
Hi, thanks, Alok. Thank you for the nice introduction. And I hope I am audible to everyone and my screen is visible.
Yes, sir.
Okay, great. So we will go ahead with this. So the topic for today is chemical data management in desktops, right? So rather, I put it across as desktop solutions for chemical data management. So I guess Alok mentioned quite a bit about Advent, but I'll still take a moment of yours to invite you and to discuss about Advent. Advent was founded in 2016, so we are a 8 years old company, and we are majorly distributing softwares in the life science domain, particularly with particular focus on molecular modeling, bioinformatics, chemoinformatics, lab data management, data analysis like life science data analysis tools and things like that. We also provide support for the first level of support for most of the solutions that we are providing in India. And we are actually very highly appreciated by our clients for our support. I have been working with Chemaxon for the last, I guess it has been more than 15 years now. Since I actually started my work in NCL over there, I was actually a user of Chemaxon, end user of Chemaxon. And that's when after that, after NCL, Chemaxon became my profession also. Like I've been associated with Chemaxon quite a long time. One of the key things that we want to do is we want to give our users a very high ROI on their software usage, and one way to do that is to provide very good support. So it's not that we are just saying this. We have also ran a survey in November, in which we had very good rating. Like on a scale of 1 to 5, how will you rate your support? 100% of our users rated it 5 out of 5, and you can see from this pie chart below that, like 50% of our users say that we provide support or we respond to their queries within less than 1 hour, and in less than 3 hours was selected by 35% of the students, and in less than 24 hours was selected by the rest 15%. Okay, so moving on, our partners include Chemaxon. We are going to talk about Chemaxon today, particularly its data management solutions. Then we also have software solutions for MoreSoft, which is more into molecular modeling, virtual library screening, QSAR, admit property prediction, then pharmacophores, homology modeling, and the likes. We very recently tied up with Satara also. In Satara, we are providing, we are rather representing their D360 portfolio, which is providing more of a solution in the integrated data analysis and data visualization for medicinal chemists. So basically, that tool D360 sits on top of your ELN or your data lake, and it can get data and assimilate data and give you very good insights. Then we have Compass, which is AI-assisted lead discovery and reaction-based design. Key module, which is optical structure recognition, like converting an image of a structure to a editable structure with one click. Transgene is a Bangalore-based company which we represent, and it has solutions for ELN, chemical inventory, compound data management, animal house, so on and so forth. So if it is something related to a custom development, you can always contact us for Transgene. Some of our users, we are very widespread users across India, across the length and breadth of the country. So you can see over here logos of some very well-renowned pharma companies, academic institutes, and so on. Now coming to the main topic, that is chemical data management on your desktop using Instant Jchem. Now, before I move into Instant Jchem, I would want to tell you that Instant Jchem is provided by Chemaxon. Chemaxon is almost a 26 years old company now. It was founded in Budapest by two chemist brothers. It was later as in last year, it was acquired by Sartara. And Chemaxon is globally known to provide industry standard softwares for chemical data management, stereochemistry handling, chemical structure search, physico-chemical property prediction, managing the DMTA cycle, chemical compliance, and so on and so forth. Chemaxon also offers a very robust portfolio of tools for managing Markov structures. So if any of you are associated with IP handling, they have tools for handling Markov structures and generating Markov patents and things like that. Now, all that we have been waiting for, moving to Instant Jchem. Now, what is Instant Jchem? So Instant Jchem is a very versatile chemistry solution, like a chemistry database management solution. So it is basically how some of our users call it is as the Swiss knife of chemical data management, right? So depending on your use case, there are a lot of functionalities or a lot of modalities or workflows in which Instant Jchem can fit into. Some of them are mentioned here. One of them is compound design. So you can build and manage relational data models. You can build and manage your chemical data along with the biological data, toxicological data, and analyze them. You can do data visualization. There are plenty of charts, graphs option that can be used to manage your data and visualize the data. Instant Jchem can also be used for patent drafting, as in you can create a library of Markov structures and then do a substructure search or a query structure search or query structure or do the search using the query structure to understand what is the coverage of your compounds in a particular Markov or in a library of Markov structures. So that basically also helps you in understanding how is your compound covered in any of the Markov structures or not. Now, it is very important to mention here that I will be continuously speaking about chemical data management, chemical databases, but it is worth noting that Chemaxon or us, we do not provide a chemical database. By that, I mean, we don't provide the chemical content or the content of the database. We are technology providers. So we are providing you the technology which will help you to build your own chemical database, right? So IGC, which is the short form of Instant Jchem, supports a wide variety of popular relational database management systems, right? So like if you're using at the backend, you want to have Oracle, MySQL, PostgreSQL, SQL Server, any of these technologies, then you can use Instant Jchem and connect to that. Now, when you install Instant Jchem in your system, it installs a database called as Derby database along with which is bundled along the installer. So if you're handling tens of thousands of chemical structures, you don't need to use any of these if you don't want to. Of course, you can still use them. Also, what can be done here is that if you're using this kind of databases, you can handle many more number of structures, right? You can handle millions of structures in the database. Now, when I talk about building, building a chemical database, there are different chemical modalities that can be managed. Just one second. Alok, can you mute yourself? I am getting an echo here.
It's already muted, sir. I'll check it.
So when you are building your chemical databases, obviously not every one of you would be interested in just chemical structures, right? So Instant Jchem also supports a lot of these different modalities or different types of chemical structures. So if you have chemical structures like complete chemical structure, you can store them, search them. You can store reactions, and you can use the Chemaxon's reaction fingerprint to do reaction searching, reaction similarity, similar reaction search, or substructure search within reactions. You can also store Markov structures. So what do we mean by Markov structures? So right, you can store the Markov structures along with the R group definitions and then search the structures using your complete structures or anything like that. Okay. Then you can also search for query structures. So Instant Jchem is very versatile, as I said, right? You can maintain a simple database which can be hundreds of molecules, or you can maintain complicated databases that are as complex as, let's say, Drug Bank or Chemical. I personally have recreated the entire Chemical in my database, in my Instant Jchem some years back. So it is very, very versatile and it is very capable of handling any kind of chemical data management tools. Now, one of the important things that why you should use Instant Jchem is that you should use Instant Jchem to convert your unorganized data into standardized format. Because the way we store our data, typically how most of us store our data, it is not useful. We cannot derive value out of it, right? So Instant Jchem can take the input in any of the file formats that is mentioned over here. There are a lot more file formats also. And it can convert them into a very easily searchable chemical database, right? Now, why do we want to convert our unorganized data to standardized data format? Because the unorganized data is unstructured, it is scattered, it is not easily searchable, it cannot be easily used to convert data into information or knowledge in the knowledge pyramid. It cannot be used concurrently, it is prone to data loss. We are not sure that we are not reinventing the wheel, right? If you don't know what has been done, how can we be sure that whatever we are doing is absolutely novel, right? So using a tool like Instant Jchem, we are going to be able to convert this entire thing to be a structured database, a compiled database, a easily searchable database, a database that can be used to easily convert data into information or knowledge. It can be used concurrently. You can share it with your colleagues. It provides data security and ensures we don't repeat our existing work. Okay. So, basically, if we are talking about converting data into structured databases, so basically what we also suggest is that you can use these two tools, which is a structure checker and standardizer. So basically, in structure checker, it checks for the authenticity of the structure and the correctness of the structure. By authenticity, I mean the correctness of the structure. Is there a bond length error? Is there a valency error or something like that? And in standardizer basically canonicalizes the entire database. It makes the database standards. Like for example, in chemistry, you can draw structures in multiple different correct ways, right? But the chem software does not understand. It's not just about Instant Jchem. Any of the structures that are structure storage databases that you use would be using the structures or storing the structures as fingerprints or as smiles, right? So if there is a chart information in your compound and the query does not have charge information, it will not match. So that is the kind of problem that Standardizer tries to solve. Now, how do you browse and interact with your data? You can view the grid view, which is like a spreadsheet view. You can also view the form view, which is more elaborate, and it gives you information about, let's say, you can see a lot of data in one single screen. This is very useful when you have relational data. That means a one-to-many relationship, right? Like, for example, a single compound has a relation with multiple data points, right? Like assay data and things like that. So those kind of things are basically useful here. Like for example, in this case, you can see you can put out your logo. You can get a tabbed pane. For example, if this particular structure, it has the chemicals data coming from one table, molecular properties coming from another table, assay data is in another tab pane which is coming from another table. Okay, so apart from having the grid view and the form view, what you can also do is you can have conditional formatting, which is majorly useful for understanding the trend of the data, giving a very good visual look into your data. Then you can have charts, and different kinds of charts are there. What you can see here are scatter plots, histograms, box charts, and box plots, as well as radar charts, right? So this combined with the chemical structure searching capability provides a very good analysis tool, right? Now, this charts are obviously synchronized with the background data table. So whenever you are doing any kind of selection over here, your structures are selected in the table and you can very easily store them in a separate table as a separate list or export them. Now, how more you can interact with your data. So one of the things that you can do here is if you have structures in your database, you can live stream them via a web service. And what do I mean by live stream is that you can send those structures to Campbell and get the associated data back to Instant Jchem. You can also now, in the latest updates, you can also store like aggregated value data values in the spreadsheet widget. This aggregation is done based on a particular aggregation logic. You can have graphical representation of mass spectra based on raw data. For example, you can, if you have the raw mass spec data, you can very well plot the mass spec that you can see over here in the form view or in the grid view. You can also have pie charts that can be visible to you. You can have histogram plots also, or bar charts also that can be there. Now, coming to chemical term, which is okay. Probably like, let's say, before I go into chemical terms, I would want to stop here and want to understand if anybody has any questions whatsoever. Alok, are there any questions?
Yes, sir. We have received some questions. Should I address them now?
Sorry, Alok, I cannot hear you. Your mic is not set, I guess.
Am I audible?
Yes, you're now.
So we have received some questions. So should I address them now?
We can take one or two.
Okay. So the first question is, can we store images like TLC plates, NMR spectra in this software?
Yes, we can. Although it is not very highly recommended, but we can store images also in this database. When I'm doing the demo, probably I will get into it. Okay.
Yes, sir. So another question is it free for academics?
It is not free, but there is a very good academic package that we are offering that can be looked up at our website, and it is very cost effective and anybody can afford that. Okay. So I guess we will store the rest of the questions and we will move ahead. Now, I was talking about chemical terms. So before I go into chemical terms, these are the typical things that we will use in the demo. So which is important is this chemical terms. The chemical terms basically is used for calculating physico-chemical properties or predicting physico-chemical properties. As you can see in the slide, there are, let's say, for example, if you see here, right, then you'll see that log P, log D molecular weight. You can have this kind of calculation, or you can even calculate the IPAC name. You can have filters like this. Actually, the chemical terms is an editor over here. So you can create a custom chemical terms by using the chemical terms language within Chemaxon. Okay. Now, what more ways to browse and interact with the data would be a structure search. Okay. So Instant Jchem's chemical structure search is one of the most advanced structure searches that is available in the market. So you can do different kinds of structure searches like simple substructure search, duplicate search, fragment search, or superstructure search, similar structure search. All of these kind of structure searches can be done. Okay. Now, as you can see here, if we do a substructure search, then obviously there's a hit highlighting that shows what are the molecules or which part of the molecules are matching my substructure query. You can see over here that it is very complex in terms of you can add OR modules, like you can add a Boolean operator on or and, which can look into these molecules. In this query, if you see here, it will look for this structure and this chemical terms, or the molecular weight in this range, or this substructure and this criteria. So you'll get hits which matches either this or this or this, right? What you can do is you can change this to and have different criteria altogether also. Another very important feature of federated search is that you can do search across all different databases in one single go. Okay. So in this case, like for example, we did a structure search of this and we had the hits from the three different data tables. Now, whenever we are doing structure searches, all the data is stored in list and queries. I will discuss more about this during our demo. What more you can do is you can also do R group analysis or R group decomposition. So if you have a congeneric series of chemical structures, you can draw a query with R groups designated there, and it will give you what is the scaffold, R1, R2, and R3. All will be created over here. Now, if at all, like even though I say that like Instant Jchem is a Swiss knife, it is very versatile and things like that, there are still certain situations where Instant Jchem is not a direct fit. But you don't have to worry about that because Instant Jchem is very customizable, because it is using the Groovy script. So you can also contact us, or you can, if you are capable enough, you can do it yourself. You can customize Instant Jchem for different kinds of data import, for input data validation, structure search and manipulation. Using this customization, people are using this as a chemical inventory. People are using this as a makeshift registration system. So there is the possibilities are endless if you are willing to go ahead and do the customization based on the professional services. Import and export. So basically, it supports all the different standard file formats and structure file formats. You can also import from CSV tab and tab and text file formats. Now you can also import from documents. But then this requires an additional license of document to structure, wherein what it does is, whenever you are importing a PDF or doc, it will go through the document one word by word. It will find out the IPAC name, common name, smiles, and it will convert the structure and will put it into the database. While exporting, you have the most standard ones that are there. So Excel file, SD file, RD file, and all of these options are there. Now, coming to the IJC bundles. What IJC bundles are basically, so Instant Jchem by default, if you license out, you will get all the data management functionalities, but what we will not get is the chemical terms, right? Let's say, for example, the physico-chemical property calculations, right? So there are three different bundles that has been created: the structural bundle, the medicinal chemistry bundle, and the computational chemistry bundle. So the structural bundle has some of the minimal or the basic calculations like hydrogen bond donor, acceptor, and things like that. Whereas the medicinal chemistry bundle has a lot of additional calculations like log P, log D, TPSA, PK, solubility, the hug model, blood-brain barrier, MPO, all of these calculations are included in this, right? So along with this, I also told you, if you remember during the presentation, that the standardizer and structure checker are licensed separately, but those are included in these bundles. So if you take the medicinal chemistry bundle or the computational chemistry bundle, you will also get, you'll also have the included standardizer, the naming conversion. So for example, if you have a list of structures and you want to get the IPAC name for all of them, you can do that using these bundles. If you have a list of names, you want to import them into Instant Jchem and convert them into structures, that also can be done using these bundles. And the computational chemistry bundle has everything that the medicinal chemistry bundle has, and it has Markush enumeration and reactor. Basically, these are the two additional tools that you'll get in the computational chemistry bundle. The good thing about this is that this medicinal chemistry bundle, which is very useful for medicinal chemists and is quite useful in the industry, this bundle and the computational chemistry bundle are also available to academics as an academic package, right? That's what I was referring to. So you can refer to our website to learn more about these bundles, and they are provided at a very, very affordable cost. Like on a per month basis per student, it costs less than a coffee in these days. So it is very powerful tool for managing your data and understanding what industry standard chemoinformatics softwares are. Now, another thing that is an extension of Instant Jchem that we will not deep dive into during the demo today is Plexus Connect. So Instant Jchem is a thick client application, meaning that it has to be installed on the desktop and you have to be there, or you have to connect remotely to that desktop to be able to access the tool. Whereas Plexus Connect is an extension of Instant Jchem, right? So it is a web-based tool. So for this is the architecture that you can see. So Instant Jchem is the server here. So Instant Jchem can be connected to the Jchem base or Jchem cartridge. These are different Jchem engines that we are talking about. When we talked about the databases like Oracle, MySQL, PostgreSQL. So these are the databases, the cartridges that are sitting on top of them. And you have Instant Jchem and you have Plexus Connect. So the user browses through the Plexus Connect, interacts with the Plexus Connect through a browser, which can be accessed on your tab, on your phone, on your browser. Just like, for example, let's say you have a web-based access of drug bank or something like that. So this is the container that contains everything, and you access it, or the user access it using a browser. Now, how is Plexus Connect useful? So this is basically a discovery tool, right? So it is not useful if you are going to be a power user in terms of uploading data, managing the security of the data and things like that. But it is very useful if you want to browse data, sort the data, export the data, analyze the data. So it's a browser-based tool, right? So it's a thin client interface. So you don't have to have an installation at every user instance. So it is very, very straightforward to use. Now you can customize how it looks from Instant Jchem or from Plexus Connect only. The idea of Plexus Connect is that as soon as a medchem or anyone comes to the interface, it should be very intuitive to use. It should be ready to use. There should not be a lot of time that he needs to get used to the interface, right? In Plexus Connect also, you can do structure searches, you can do plots, chartings, conditional formatting, almost everything, but in terms of the data analysis and data visualization. So as you can see, this is one of the makeshift mini registration system that is casted onto Plexus Connect, made in Instant Jchem and visualized in Plexus Connect. There are these different kinds of data analysis tools that you can see, like it is visible in Instant Jchem also. And as I said, you can have custom conditional formatting. You can have very good quality images that are ready to print. It also supports blog fields now. So if you have the Oracle text index, that can be queried with Plexus Connect also now. Okay, so that is majorly most of it. If there are no other questions, what I will do is I will quickly switch to the demo.
We have some more questions, sir.
Okay.
So the next question is, how many structures can be stored and searched in this database?
So I guess I answered that earlier, that if you are using the a bundled Derby database, it can be tens of thousands, and obviously it is dependent on your machine configuration also. But if you want to handle corporate databases or ultra large databases in terms of multi-million molecules, then you would have to have a cartridge at the back end, and the data has to be stored in a dedicated database like a Postgres cartridge or a MySQL server or a Oracle server. So technically, there is no limit on the number of data you can store. We even have conducted structure searches on maybe around 720, 750 billion, a million structures using not Instant Jchem, but the database technology that we are having.
Oh, okay. So the next question that we have is, does documents as PDF consider patents as import?
So you want to import PDF documents into the database.
Yeah.
So I guess the use case would be that if you are having a reaction and you want to import and you want to also have the PDF associated with that reaction, let's say ELN page or something like that. So typically we don't recommend that, because the idea of any database is to make the database compact and more searchable and more fast in searching, right? So when we are associating PDFs, it tends to make the database slow. But then how are our users solving this problem? So typically they will share or rather store the PDFs in a shared drive, and along with that in that particular row or in that particular structure with which the PDF has to be associated, they will provide the link as a HTTP link or any of the links in that particular associated with that particular compound. So the user can click on that particular link and he can be redirected to the page which opens up, or to the folder which opens up the PDF file. Okay. So now let us go ahead and get started with this demo part. I guess we have another 20 odd minutes left. So what I will just quickly take you through the interface of the Plexus Connect, Instant Jchem. So over here we have a new project. We will get into the details of that. If you have click here, it's an open project. So basically you can open an existing project. So when we click on a new project, so this is what I was talking about. So there are three different options. IGC project, local database with demo data. This is with local database without the demo data, and it is empty. So when you click any of these two options, it will use the Derby database at the backend. If you click on this, so for example, let's click on, we'll close this project. Now you see it is empty. Now you can connect to an IGC schema. So these are the databases that I was talking about. You remember? So you can connect to any of these databases and then store the data there, right? So in our case, what we will do is we will go ahead and create this embedded Derby. So let's say we will name this as demo webinar. Now you can see we have created this database. Now I am logged in as an administrator. What I can do here is I can now say that, okay, I would want to create a new data tree with structure entity. So if I want to store structures, I will create this structure entity table. If I want to store associated data, I will create this standard entity table. Okay. So let's say, for example, I create a new structure entity table. Okay. Now, when I come here, I have the option to store. You can see there is the option called table contents here. So if I click on this, I can store molecules, reaction, Marcus libraries, query structures, any structures. So any structures can store any of the above, but it is not very optimized when it comes to searching. Now let's imagine you would want to prohibit the duplicate structures coming into your database, right? You want to always maintain a unique set of compounds in the database. So if you click on this, it will filter for duplicates. So whenever you are entering a compound into the database, it will check it against all the structures that are there in the database, and it will tell you that, okay, can it be imported or it cannot be imported, right? Then if you want to allow empty structures. So in Instant Jchem, the structure is considered as the primary element, right? So everything else is associated with the structure. Now, if you want to allow empty structures, that for example, for compounds for which you are not yet sure about the actual chemical structure, so you can still make this option available over here. But if you say that empty structures allowed, then it will allow a structure field to be blank, which you can later fill also. Okay, it will also check for duplicate tautomers and things like that. Now, the ID generation is automatic with JChem standards. Then you can choose the fingerprint length. What is more interesting here is the standardizer that I was talking about. Okay. So what you can do here is you can create a standardizer. Now you can see there are so many options. There are 64 standardizers that are there. Now, if I, let's say, for example, want to go ahead and say clean 2D, right? If I just say it here, then you will see that after adding, I can get a lot of options also. How do I want to clean it in 2D? Now, let's say I want to add this transform nitro, right? So what this does is that it tells the software that either this or this should be treated as the same structure, right? Now, what you can see here is that this is a standardizer and there's a chemical structure over here. If I double click on this, it opens up Marvin sketch, meaning that I can edit this, or what I can also do is I can add my own standardizer also. Okay, so these are the scheme, these are the options. How do you want to match the queries? So you can create your own standardizers also, so that the database that you're creating is standardized. It does not have the chemical errors. Okay, so I click finish. Now it will say that it has created a database. Now over here, it is important to mention is that by default, I'm redirected to the query window because there are no structures now. If I click on the browse, I'll see that the ID, structure, mole weight, and formula are automatically created. Now, if I want to add a structure, I can just go here, open Marvin and add them. You'll see that the first one will take a bit of time. So it will add the structure and then it will automatically add the molecular weight and formula. It will not close this by default. The idea is that if I want to create some more molecules, I don't have to open this again and again. So I add it again and then I close it, right? So this is the way you can do adding manually. So this is typically useful when you're doing a lot of research and all your data is lying around in individual chemical structure files, or it is there in your basically, let's say, notebooks and things like that, right? So this is a better way of storing data. But now you will not only store molecular weight and formula, right? So you will be wanting to store a lot more textual data also. So what can be done in that case is I can create a new standard field. So for example, I create a text field. This is, let's say, submitted by. Okay. Then I can create a, sorry. Then I can create a date field. Submission date. Now, somebody asked, can we store images? So for that, I can create a binary field. Now you can see when I create a binary field, I have the images like images and all these formats, right? Let's say I would want to store the TLC image. Okay. Now you can see here. Now, if I click on this, I will be asked to import a image, right? Now, the difference that this makes is basically the idea is that whenever you are trying to create a database, you should be creating the database and you should have a clear vision of the database, right? So you should create the entire structure of the database. All the fields should be created. Why do I say this is because now if I go and add a structure, you'll see these three options are also available now. So now if I add this, I can say that it is submitted by Surajit. The submission date is, let's say, 12th February. And if there is a TLC file image, I can just browse it and put it here, right? So that ways the possibilities are endless. You can create as many number of columns, as many you want, whatever suits you the most. Okay. The other way to do this is I can just right click here. I can say import file. Okay. So I have a structures file here. As I said, you can see there's a lot of different file formats from which it can be imported. I will click on OK. Now it automatically tries to parse the file and understand what is the content of the file. So by default, you'll see that it is understood it's a molecule file. Okay. And it has created a JChem based entity. I'll click on next. Next. Now it will import the data. Now 392 data structures are there. Now you can see it has imported the data directly, and you can see these are editable structures and everything. Now, what I have with me, if I go to my desktop here, and what I have with me is that I imported this structures data. What I have with me also is this CSV file, right? So you can see it's a Microsoft CSV file. So it has some assay ID and some values, right? I would also want to import this. But I have 392 structures and I have 1020 values here. So what does this mean? This means that the structures are having a one-to-many relationship with that particular sheet that I'm creating. So what I will do here is I will just go ahead and I say import file and I say activities, open, and you can see it has automatically detected it is not a structure file. So it has created a new database table and you can see there is no structure molecule and things like that here. Okay. So I'll click on next, and I just finish this. It has imported it like an Excel sheet here. Okay. Now what I want to do is I would want to see both the data together. Okay. So we will not do a lot of in-depth analysis on this today, but what I will want to do show you that it is very easy to create. So I will go ahead and say structures, and sorry, I should be in the data tree structures, and I should have something. I would create a new relationship and it's a many to one. So for example, from structures to activities, what is the, so in both of these, if you want to create a relation, there has to be a unique identifier. So in my case, the unique identifier is this mole registration number. Okay. Click on next. I say that this is the parent table, activities is going to be the child table, and I click on finish. Okay. So now you can see this icon has changed. This is a relational table now. So if I go ahead and say we were seeing till now, this is the grid view that we talked about. Now I told you that we can create a form view also. So if we create a form view here and you can design it, I right click and I say that, okay, I would want to have a molecule pane here. And then I right click and I say that I would want to have a table. You can see both the tables are here. So I am not creating something that is very beautiful to look at right now. But if you say I can bind this here and I can create another table which has the chemistry based data here. Okay. Or what I can also do here is I can also create a container, okay, a tab pane. And I can say that, okay, this is chemistry and I can add assay data, right? So in chemistry again, I can add this table and I can put this data here, and in assay, I can put this table and I can put this data here. Okay. So then what I can do is if I go out, I can increase this size and similarly, sorry. Here so that I can show it to you. Now, if I go to browse, you'll see that I can have the molecule here and the assay data here. So this particular molecule, if I change this, it will change. You can see. So this particular molecule has multiple assay values. Okay. Now to show this to you, I will open up a demo project. So for example, you can see here that this is the this is one of the data trees that can be created, right? So you have other views also, like the, let's say for example, we talked about the conditional formatting widgets overview. So if you see here, this is the kind of thing that we were creating here. I can browse through the data and it can give me all the information. We can also have a charts overview, which is having the different charts that we talked about, right? So all of these options are available. So for example, if you want to see a single record and get this, so you can see you can have hyperlinks like these also. Then you can have the grid view also over here. So the views are completely customizable as per your requirements. Now, what I can do here is I can very quickly go ahead and say that I would want to do a query search, right? So let's say, for example, we set this up and we say we run the query. Right, as again, I told you earlier also, this first structure search would take the maximum amount of time. After that, all the structures are loaded into the cached memory. It will not take that much amount of time. Right? We could very easily search, see this. Now, if I want to, if I want to go to the query and I want to say that, okay, number of rotatable bonds is equal to, let's say, 3. So I get only 7 molecules. So this way you will be able to filter your compounds in a much better manner. Now we have limited data over here. So what I would want to do is here is that I would want to clear the query, show all the structures. There are 1,000 structures. And like I told you, I would want to calculate some physico-chemical properties. Let's say I would want to calculate a CNS MPO score. Go ahead and calculate maybe, let's say, the strongest acidic pK, right? And then go ahead and calculate the log P. You can see they're adding the calculations. I'm just going on adding one by one. It will calculate it once the previous one is done. Just anything like that, or maybe I will calculate the Boolean filter that how many of these filters are they following. Now you have to see that this is an editor, so I can change this, right? So instead of let's say, for example, it being 10, I can say that it being 20 also, right? So that way I can change this. So I'll put this as finish, and then I will say that, okay, in the chemical terms, what I can also do is I can press Control and space. I get a lot of options that are there, right? I can use any of them and do the property calculations, right? Now you can see that we have calculated some more, this from starting from the CNS MPO, there are a lot of properties that are calculated now, okay? Now, if I go to query again, and I want to say that, okay, give me all the molecules that are following the Lipin's rule of 5 in this database. I run the query, I get 774 hits. Okay. So then again, I go to query and I say, give me the molecules in which the CNS MPO is between 4.00 and 5.00. Okay. I get 294 hits now. Now you'll see over here, the CNS MPO will be between that range only. Okay. Now what I can do is I can, let's say, for example, I can couple this up with my structure query that we had drawn earlier, right? Okay, I can make this a bit more interesting. I can say that, okay, I will create an atom list. So atom list basically will tell that, okay, at this position, it can be any of these particular elements, right? It can be carbon, nitrogen, oxygen, or sulfur. Rather than drawing 4 different queries to solve these questions, I will try to do it in one go. Okay. Now I get 101 molecules. Now you see, in this case, there is no nitrogen here. There is a carbon here. In this case, also there is a carbon. In this case, there is a nitrogen. There is a carbon. So we are getting all different kinds of hits here, right? So there are 101 molecules here. Now, I showed you the query builder. In the query builder, you can do much more advanced things. So for example, if I go ahead and say that, okay, query builder. Now, this is the query that we have right now, right? What you are seeing, what we have done right now. So I can say that, okay, I can add an OR element. In this OR element, if I see here, I can add a field, let's say a structure, and I can say that, okay, it has to be this particular structure. So now it will search for these or this, right? I can keep on adding fields to this, right? So whatever is the condition that I want to meet, I can do that. Now, when you're doing, let me pin this here. So whenever you're doing a structure search over here, you have options over here. So you can make this structure search also very, very generic, or you can make it as specific as you want. Like, how do you want to match the stereochemistry? How do you want to match the atoms? Do you want to search for tautomers? Then is there any attached data that you want to search for? So all of these things are coming, and then you can get the results. And once you have the results, then you can directly export the results. For example, these are the results that are there, and you can directly export the structures into a file format like Excel, SDF, RDF, and things like that. Okay. So I guess we are kind of around the time limit. I'm not sure if there are any other questions.
Yes, sir. We have some questions. Actually, team is constantly filtering out questions. So the next question is, how secure is the data in your database? Am I audible? Am I audible?
Hello, Alok, I can't hear you.
Am I audible now, sir?
I can't hear you actually.
Am I audible now? Hello? 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 Hello?
Can anybody hear me or not?
Hello? Hello?
Hello.
Hello. Okay, great. Am I audible now? So I guess there is some issue with the audio. If you have any questions, I guess you can put it up in the question answer box. If you guys are able to hear me, there is some issue at Alok's end. So I would want to thank you all for sparing time to attend this webinar. There'll be more webinars coming soon. So stay tuned and please follow our LinkedIn page for the same to understand when are the webinars being scheduled. Thank you all. It was nice to have you all here. Bye-bye. Have a nice day.